today's topic. But before going today's topic, let's begin what we have studied in our previous classes and how much topic we are left with our solid state. Okay, so let's begin. Basically, if I'm talking about the solid state, we have been left with only two topics, that is the electrical property as well as the magnetic property. And hopefully the topics are very small, so within 2 or 3 lectures we would complete our chapter number 1, that is the solid state. Okay, so we have finished our solutions as well as the solid state within 2 to 3 days. Definitely we are going to finish that. The point is, hopefully you have prepared all the notes and you're revising the topic as well. As I have been telling you again and again that that chemistry is something which wants continuity, which demands continuity. If you're going to do something, if you're going to pursue it in your continuous order, only then it's easy for you. Okay, so please have a focus on this particular topic. Now let's start with the solid state. In our previous classes, in solid state, we have studied what is solid state, what are the different type of solids, what are the unit cell, the crystal lattice, and the 7 different type of unit cell. Okay, and also in the last lecture, we have just completed with our topic that was the different type of imperfections in solid, the defects in solid. Okay, now let's move with that topic that is known as electrical properties of solids. What are the electrical properties of solids? In this topic, we will discuss that our solid shows electrical properties. That means they show conduction. They can easily conduct electricity from themselves, from one portion to another portion. Okay, so we are going to discuss our solids, and on the basis of electrical property, we have differentiate our solids in 3 different topics, that is conductors, semiconductors, and insulator. Okay, but before going to this particular topic, I would tell you that our solids exhibit an amazing property, an amazing conductivity within the range of 10 raised to power minus 20 to 10 raised to power 7 per ohm per meter. Okay, and you know very well, you have studied that in physics also, and even also in 3rd chapter, that is electrochemistry. You will briefly discuss, you will study in detail what is the unit of conductivity. Why do we need to study the conductivity in this unit? Okay, so I just want to say that we have been given a perfect range order of the conductivity, that is between 10 raised to power minus 20 to 10 raised to power 7. Okay, now on the basis of this order, we have been classified our 3 topics, 3 solid, that is conductor, semiconductor, and insulator. If I'm talking about the conductivity of conductor, it shows maximum conductivity, quite obviously, that's why they're known as conductor, which shows 10 raised to power 4 to 10 raised to power 7 per ohm per meter. Okay, same as it is, we're going to move with 10 raised to power minus 6 to 10 raised to power 4. And lastly, we are having the insulators, which shows the minimum conductivity, that is known to be 10 raised to power minus 20 to 10 raised to power minus 10 per ohm per meter. Okay, now let's begin that why do our conductors conduct electricity? What is the reason behind this? I hope you have studied this topic in your lower classes, that our conductors, especially the metals, if I'm talking about the metal exhibit conductivity, they show electrical property due to movement of electrons. Whenever electrons keep moving, our metal should start exhibiting electrical property. यानी जब तक metals के पास electrons की movement हो रही है, तब तक हमारे जो metals हैं, they can show conductivity, they can show electrical movement. Okay, now our metals, that is also known as conductors, they show conductivity due to movement of electrons. And if I'm talking about electrolytes, they show conductivity due to movement of ions. Now the question is, are metals, they conduct electricity both in solid as well as in molten state. That means they can conduct electricity even if they are in molten form. Okay, now the point is, the conductors, the metals, they have some atomic orbitals We know that very well. Each kind of atom has atomic orbitals, and on combining, they form molecular orbital. And the best point is, whenever these molecular orbitals are combined, they are shown in the form of a band. I am repeating it again. Whenever our atomic orbitals, they combine, they form molecular orbital. And when these molecular orbitals are seen from a distance, they are behaving like a band. This band I was talking about, okay? These bands are of basically three types, that is conduction band, overlapping band, and the last one is unoverlapping band. Okay, now on the basis of these, we can explain how do our metal conduct electricity. Okay, so let's start with this topic. Now, as I have already told you that these molecular orbitals shows their conductivity, shows their presentation in the form of bands. If I'm talking about metals, they have unfilled band, this band is of one metal atom, this is of one metal molecule. Now I have told you that conductors show conductivity when electrons start jumping. So I am telling you, if there is this partially unfilled band and this is almost occupied with another band which is of higher position, the electrons can easily jump to this band, and this is known as our conductors or metals. I'm again repeating, we have two type of bands of two different molecular orbitals, of two different metal orbitals. One is little bit unoccupied, that means there are electrons, but this is not completely filled. And other one is completely unoccupied, this is totally empty. Now, whenever electrons, they are jumping from one position to another position, the electrons are moving, that means the conductivity is showing over there. Okay. So I can say that only on these positions of bands our electrons are moving and our metals are show conductivity. Now, if I'm talking about our semiconductor, there is also band, like a complete band, but there is some difference between these position. We can say there is a little bit gap. Now electron from this complete filled band can jump to the higher band, which is little bit unoccupied, which is little bit on higher gap, but they would do it with little bit difficulty. Why? Because there is gap, there is a distance between these two bands. So electron from jumping one level to another, they would attain some difficulty, and that's why they are known as semiconductors. They're known as semiconductors. Now, if I'm talking about insulator, the best thing about insulator is the valence band and the filled band. That is the valence band, sorry, the filled band, which is completely filled, and the valence band that is completely unoccupied. These have so much higher distance, or we can say higher gap, that electrons cannot jump from one position to another position. Let me repeat it again. I am saying that we have two different bands, as we have studied in our these particular bands, like as in semiconductors as well as the conductors. The only point was the distance. These also have two type of bands. One is completely filled, which is of electron, and other one which is totally empty. But there is so much distance between them that electrons cannot jump from one level to another level, and that's why they do not show electrical conductivity, they do not show electrical property, and that's why they're known as insulator. Okay ji, so insulator हमारे क्या होते हैं, which do not show any kind of electrical conductivity, and the reason behind them is the high distance gap. The electron have to jump so much level, they have to attain so much energy, only then they would show some electrical movement. Okay, so this was our discussion. How can we show the electrical conductivity between our conductor, semiconductor, and the insulator? Okay, I hope you have gotten this particular point. Now I am going to move with our next topic, that is semiconductor. See, conductors show complete conductivity. Insulator doesn't show conductivity at all. If you ever there is some more energy provided to electron, they would show little bit conductivity. So this and this are none of our use. I'm talking about semiconductor. There is something gap which can be attained, which can be achieved. Okay, so the next topic is electrical properties of semiconductor. And I have already told you, and I have already shown you that there is conductivity, but which is very low rather than the complete conductors. Okay, so in these topic, in semiconductors, there is electrical conductivity, but this is of little importance because there is conductivity in very poor order. So for making it in our practical purpose, we can increase the electrical conductivity of semiconductor. And this is our next topic. How can we increase conductivity in semiconductor? What is this property called? And how is it beneficial for us? Okay, so let's begin with our next topic. I'm just moving with the topic, conduction of electricity in semiconductors. Conduction of electricity in semiconductors. Let's start. Now, class, as I have already told you, that in the semiconductor, there is some distance, there is some little bit energy gap, which can attain and which can show electrical conductivity. Now, the electrical properties of semiconductors, this can be increased with rise in temperature, the first point. Okay, as you know very well that for jumping electrons from one level to another, you have studied this in 11th class also. In 11th class, I think in the second chapter, when we have studied Bohr's atomic orbital and so on. So in which we have studied that for jumping from one level to another level, that is from ground state to excited state, or from one molecular orbital to another molecular orbital, what we need energy, we need temperature. So with increase in temperature, the conductivity of semiconductors could be increased because they can easily jump from one level to another level. That is the first point. Now the second point is, we can also add some impurities in our semiconductors. We will add some impurities in our semiconductors so that these impurities would help to attain electrical conductivity. And that is the topic of our use. That is the topic we are going to study. Whenever we add some impurities in semiconductor just to increase the electrical conductivity, this property is known as doping. The property is known as doping. You have heard the word doping, right? Here, the players, they are used, they are, we can say, accumulated of that particular process, doping. So doping basically is kind of mixing of a foreign particle. It is kind of mixing of impurity in the semiconductors, and this is of our use. That's why we are doping in the semiconductor. And what would it help? It would help in increasing the electrical conductivity. Now, doping can be done by two types known as N-type impurities and P-type impurities. And I would make it that after adding N-type impurities, this would become N-type semiconductors and P-type semiconductors. Okay, so this is our next topic. What are N-type and P-type semiconductors? So let's begin with this topic. Now, class, tell me one thing. I have already described to you that there are some impurities. So what actually impurities mean? Impurity means we are adding some foreign particles. Okay. Now, if I'm talking about the semiconductors are basically which shows little bit lower conductivity, and they always belongs to group 14. They always belong to group 14. Suppose silicon, germanium. Okay, carbon is our non-metal. You know very well what are the group 14. कैसी गिफ्ट सुनाए प्रभु? Carbon, silicon, germanium, tin, lead, and so on. Okay, but carbon is non-metal. Tin and lead, these are metals. So we are left with silicon and germanium, which are semiconductors. So we will see how we add some kind of impurities, some kind of foreign particles from semiconductors. Okay, let's start with first, the N-type semiconductor. In this topic, we will add the particles of group 15. The particles of group 15. Now let's begin. What can they help to us? The group 15 particles, like the 15 particles कौन से होते हैं? Nitrogen, phosphorus, arsen, है ना? Group 15 elements contain phosphorus or arsen. We know very well that the group 15 elements exhibit 5 valency. That means there are total 5 electrons, or there are total 5 type of valence electrons which are shown by group 15. You know that very well. You have studied in 11th class. Now, what happened actually whenever we add group 15 elements? Suppose this is my complete semiconductor. Suppose this is silicon, 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 and silicon. This is something which is a complete semiconductor, a pure semiconductor. Now I am saying that I am adding group 15 elements like phosphorus or arsenic. What would happen? One of them would be replaced by, suppose I am saying arsenic element. Okay, I have some. Now, as arsenic show 5 different valencies, so what would happen? This electron. Okay, let me show that these are the electrons, and there is a one single electron. Now, what would happen? The 4 electrons of the arsenic, they are used to make covalent bonds of silicon, because we have added them, and this is the nature, this is the property of our compounds, of any kind of compound, that whenever they get a chance, they make any kind of bond, either it is a covalent bond or ionic bond or something. Okay, so these 4 electrons are used up to make covalent bond with silicon with semiconductor particles. Now the 5th one, the last one electron, this is extra. This is extra, so it would start moving. So this is a mobile electron. Okay, so this moving electron, which is extra over here, it would start moving, and it would keep increasing the electrical conductivity, because due to movement of electron, the electrical conductivity is possible. बात समझ में आ रही है? Due to movement of electron, electrical conductivity is possible, and we have one extra mobile electron, due to which the electrical conductivity of our semiconductor is increased. Now, this is due to negative electron, so we call it N-type semiconductor. That means negative electron, from negative N, we get N-type semiconductor. बन रही है जी बात? So group 15, in which there is one extra negative electron, due to that extra negative electron, there is increase in conductivity, and hence we call it N-type semiconductor. Hence we call it N-type semiconductor. Okay. Now let's move to P-type semiconductor. How is it different from N-type semiconductor, and how can it help us to increase the conductivity? Okay, so let's move. Now class, I'm damn sure that you have completed the topic, you have completed, gained the concept that whatever we are doing in the doping, either in N-type or either in P-type, we are adding an extra foreign particle to it, okay? So that it would lead to some disturbance and it would increase the conductivity. So let's see how the P-type semiconductor help to us. I want to show you the 3 diagrams so that you can easily differentiate them. Let's see about the P-type semiconductor. Now, in N-type, we have added group 15, and in P-type, we are adding the elements of group 13. Okay, Ji. Now, how group 13 would help to us? Okay, the first point is group 13 elements are something like boron, aluminium, gallium. That is the group 13 element. The group 13 element are electron deficient compounds. Why? Because we know that 13, 14, 15, 14 shows complete 4 electrons, 15 show 1 extra electron. So group 15 are also known as electron rich compound. Okay. And group 13, they will show only 3 valence electron. So this would be known as electron deficient compound. Ban rahi hai ji baat? Now, how this electron deficient compound would help to us? We are adding the foreign particle, the particle of group 13. Suppose I'm adding boron. Now, we are having the silicon as usual. And in this, we will add a foreign particle. Suppose I'm adding boron over here. Okay, and same as it is. Okay. Now we know very well that boron has only 3 different electrons. Okay. And all these 3 different electrons would be covered up, would be made up to make covalent bond with the silicon atoms which are near to it. Okay. These are covered up to make a compound, or we can say to make bonding with different silicon atoms. So now there is a valency, there is a kind of hole. Yes, there is a kind of hole in which is empty over there. So we need to move this electron to it so that the hole would be completed. Okay. Now, if the electron would displace its position, there would be another hole created. Am I right? I'm saying that this electron is moving to it, but if it would be so, there would be hole created over there, and same as it is, the hole would be created over there. So it shows like the hole is moving, the positive hole is moving rather than the negative electron. Okay, it seems so, but actual point is electrons are moving. But if electrons are moving again and again, there would be creation of positive hole, which seems to be that hole is moving from this direction to this direction to this again and again. Okay, so due to this positive hole, or we can say due to movement of that particular electron, the conductivity of insulator would be increased. And this is due to positive hole, so we call it P-type. Due to positive hole, we call it P-type. P for positive, P for P-type, same as it is, and for negative, and for N-type. Okay, so this is the difference between our group 13 and group 15 doping. 13 is electron deficient compound, whereas group 15 is electron rich compound. But both have the same property, both have the same nature, that is to increase the electrical conductivity of our semiconductor. Now you can see the differences between these 3 diagrams. This is our pure semiconductor. This is our N-type semiconductor, in which there is an extra mobile electron. whereas in p-type semiconductor there is a positive hole. There is deficiency of an electron which would lead to increase of our semiconductor. Okay, so this is known as our p-type semiconductor. बन गया जी बात? So this was all about n-type as well as p-type semiconductors. Now the point is how they are beneficial to us. What are the applications for n-type and p-type semiconductor? Like we have made them, we have tried to just go over them. The point is what are its beneficial, what are its uses. Let's complete this topic within 3 to 4 minutes and then we will have a recapitulation. Okay, so let's start. What are the benefits of our semiconductors? Advantage of n-type as well as p-type semiconductor. Now the first point is quite obviously it has increased the electrical conductivity. So this is the biggest advantage. Okay. Now the point is with the help of n-type and p-type semiconductor, we can make our electrical appliances like diodes, or we can make transistors, which helps to, transistors help us to enhance the radio signal, the audio signal. You have heard about them in physics. Okay, so this is the biggest advantage, that we can make some electrical appliances, some electrical compounds from them, like as diodes, transistor. And these are formed by sandwiching the layer, like NPN conductor. First is their n-type conductor, then we are having a p-type conductor, then we are having n-type conductor. So this is a kind of sandwich in which we are sandwiching the p p-type semiconductor between two n-type semiconductors. Okay, so this is the biggest advantage. And other than that, we have some other example, like we are having, rhenium oxide. But say this question, this would come definitely in your MCQs. Let me check. I have written something wrong. Yes, rhenium oxide. That is ReO3. This is the only semiconductor which behaves as metallic copper. This would definitely come in your MCQs. This is important. Okay. So keep in your mind that rhenium oxide, that is ReO3, this is the only semiconductor which behaves as metallic copper. So this is something which has so much electrical conductivity, which is almost comparable to copper. Okay, so keep in your mind that this is the semiconductor which has been made by increasing n-type p-type semiconductor. Okay, so this was all about the advantages of n-type and p-type semiconductor. Now let me recapitulate what we have studied, and definitely then we will move with your query session. Okay, so let's start what we have studied today. We have studied our electrical conductivity, in which we have studied that our solids, they show three different type of properties, that is metals, these are known as conductor, semiconductor, and the last one is insulator. Conductors, that means they show complete conductivity due to movement of electrons, and the insulator, which does not show the conductivity at all, and even they show very little bit conductivity. The insulator, they are in the mediocre stage, they are in between the two, and they can show electrical conductivity. So for making it for our purpose, we can increase that electrical conductivity by two methods. First method is by just raising the temperature, and second method is by doping. Doping means we have added some kind of, foreign particles कौन से हैं? The group 13 and the group 15. Group 13 electron deficient, which means positive hole would be created, which are known as p-type semiconductor. And group 15, that means electron rich compounds, in which extra electron is over there. So due to an extra electron negative charge, we have n-type semiconductor. Okay, n-type semiconductor के example कौन से हैं हमारे? Group 15 like phosphorus and arsenic, and p-type के group 13, that is electron deficient, boron और aluminum. और हम किसके अंदर ऐड कर रहे हैं? Into group 14, because group 14 में we have two semiconductors importantly, silicon and germanium. Okay. And lastly, when we have doped them, when we have increased the conductivity, we have seen what are the advantages, what are the benefits, and these advantages and benefits are for making some electrical appliances like diodes, like transistor, and so. Okay, so this was all about by my side. This was all about the n-type, p-type semiconductor. Now